Okay, epithelial tissue, we continue. We have the pseudostratified ciliated columna, So you can see that they have a line in the trachea. Why is that? Okay, in trachea, that means a windpipe. We have this type of cell, they call it goblet cell. Goblet cell is the cell that can secrete mucus. And the mucus can trap the dust or microbes or bacteria or microbes in the trachea so that the cilia, they can move the mucus out so that we can cough it out. So that's why this pseudostratified ciliated columnar epithelium, they are the lining of the trachea so that they can produce they can serve as a barrier, as a first line of defense, and they also attach to the basal membrane. Because pseudostratified, because it's only one layer, because all the cells attach to the basal membrane, but it's just that the way they arrange it looks like they are multiple layers. Or you can see that the nuclei, they do not line up into one straight line. Some nuclei, they are higher, some nuclei, they are lower. So that it makes them look like they are multiple layers. Stratified squamous, meaning that they are multiple thin flattened cell. Multiple flattened you can find in the skin epidermis. You can find it in the nose, mouth, esophagus, anus, and vagina. But the one that I would say is the skin is the easiest to memorize. When you take anatomy, you learn the details of the skin anatomy. We have 4 to 5 layers of epidermis. The first 3 layers of the epidermis, they are actually dead cells. The last 2, the under 2 layers, they are live cell, and the bottom layer of the epidermis, they are actually actively dividing. They are under active mitosis, so that they can push upward to replace the dead cell on the top. And then simple columnar cell. Simple columnar cell, again, they are one layer. They also have a goblet cell. Where can you find it? You can find it in the small intestine, uterine tube. Whenever you see this is a simple, that means one layer, most of the time they are for absorption or exchanging substances. And they are, you can find in the small intestine for absorbing the nutrient. And you have goblet cell in your small intestine so that you can secrete mucus to lubricate the movement of the peristalsis, lubricate the movement of the food down your GI tract through by the peristalsis. Simple cuboidal. Okay, there are 2 types: simple cuboidal and stratified cuboidal. All cuboidal cell, they make tube. They make tube. Okay. Simple cuboidal, they make smaller tube, kidney tubule or various gland. Stratified cuboidal make a bigger glands. We'll talk about that later. So simple cuboidal make the small gland, the small tube in the kidney tubule for filtration or reabsorption of the fluid. And then because they are one cell, one layer, so they can absorb, they will allow the movement of the substances going in and out of the tube. So cuboidal, they always form a tube. Simple cuboidal form a small tube. Stratified tube make a larger tube in a gland. Oh, so they didn't talk about the stratified cuboidal. Stratified cuboidal, I can tell you that stratified cuboidal, they form larger gland like salivary gland, mammary gland for production of milk in the breast, and also the sweat gland. Those larger glands, they have the tube that is formed by a stratified cuboidal. Simple cuboidal, just kidney tubule, that's good enough. We will talk about kidney tubule when we go to the urinary system. So this is the summary of the epithelial tissues. So, as we know that epithelial cells, they connect to each other. What connects them? Well, we have different cell junctions that can connect the cell together. First one is called tight junction. They are impermeable barrier. Where you find the tight junction, for example, you can find tight junction in the simple columnar epithelium in the GI tract. So the tight junction there, the tight junction there separate the lumen of the GI tract with the blood behind it, or you can also find this tight junction in the testis, so that it can separate the testis with the blood vessels. So the tight junction, you can find it in those areas. Gap junction, when the two adjacent plasma channels join, where can you find it? For example, you can find it in your heart muscle. Gap junction literally connects the two cells into one. So the cytoplasm of two cells will become one, and then so that when one heart muscle cell contract, then all other heart muscle cells will contract at the same time because of the gap junction connecting all the cytoplasm together. And then adhesion junction. Adhesion junction, adjacent plasma membrane do not touch, but held together by intercellular filament attached to cytoplasmic plaques. This one, you can find it generally in many cell type. And then connective tissues. Connective tissue, they bind organs together. For example, they also have supportive and protective function. They fill spaces, they produce blood cells, they store fat. Connective tissue, they have two important components. They have the cell, connective tissue cells, and then they have the tissues. So they have the connective tissue cell, and then they have the matrix. They have the matrix, yeah, connective tissue, and then they have the matrix. Matrix, they can be solid, semi-solid, or liquid. In the matrix, you have different fiber and protein there. In the matrix, you have three types of fibers: collagen, elastic, and reticular. Collagen fiber, they are the biggest in size and they are the toughest. If the tissue have collagen, it will make the tissue very, very strong. It gives the flexibility and strength. Elastic fiber, they are the second. They're the medium size. As the name suggests, elastic fiber, they are stretchable, they are elastic. And reticular fiber, they're the thinnest, the weakest one. They form supporting network, highly branched.